Welcome back. This is Mrs. Rubright with Algebra 1 Honors, and today's lesson is 2-3, solving inequalities by multiplying or dividing. All right, so let's look at what we're doing here. We're multiplying or dividing by a negative number. The following two inequalities are true. 4 is less than 5. 15 is greater than 12. So the alligator always eats what's bigger. You would rather have $15 over $12, or you'd rather have $5 over $4, right? The alligator eats what's bigger. This is the alligator's jaws. What happens to inequalities if you multiply both sides of the first inequality by 4 and both sides of the second inequality by 3? All right, so if we're multiplying both sides of the first one by 4, we would have 16 is less than 20. And over here, if we're multiplying this one by 3, 15 times 3 is greater than 12 times 3. 15 times 3 is 45, is greater than 36. So they still are true, right? Both statements are still true. 16 is less than 20, and 5 is greater than 4. Wait, did they say to divide? No, I did this right. I'm just reading the wrong thing, I think. Hold on. Both statements are still true. 16 is less than 20. And 5 is greater than 4. Oh, the second thing was to divide both sides by 3. I didn't read the second part very well. So we were supposed to divide. So if I was dividing by 3, I can just fix it. It's a fraction. 15 divided by 3 is 5. And 12 divided by 3 is 4. So if you multiply both sides by the same number or divide both sides by the same number, it should still hold the statement true. Now multiply the first inequality by negative 4 and divide the second inequality by negative 3. So 4 times negative 4 is less than 5 times negative 4. And 15 divided by negative 3. I don't know why I made parentheses. That kind of looks silly, huh? Looks silly, right? Let's just do a fraction bar. It looks nicer. 15 divided by negative 3 is greater than 12 divided by negative 3. Okay, so we'd have negative 16 is less than negative 20. Here we would have negative 5 is greater than negative 4. Okay? This is not true. You don't want to be, negative numbers is debt. That's owing your mom money. Do you want to owe her 20 bucks or 16 bucks? It sucks to owe her money either way. But if we're going to owe her, let's owe her less, right? So the smaller the negative number, the better it is. I'd rather have negative $1 than negative $1 million. Because negative $1 million is going to take me my whole life to pay back. Or negative $1, I can pay that back tomorrow, right? So, these would not be right. And the reason is, when you multiply or divide both sides by a negative, you have to flip the inequality symbol. So repeat the multiplication and the division, but this time reverse the inequality symbol when you do it. So if we're doing the same thing, we would have negative 16. We flip the sign. Keep, change, flip, right? Or keep, change, opposite. Keep, change, opposite. Now this is a true statement. So when you flip the sign, it fixes it. So anytime you multiply or divide both sides of an inequality by a negative number, you must flip the sign. When solving inequalities, if you multiply by a negative number, you must flip the inequality symbol. When solving inequalities, if you divide by a negative number, you must flip the inequality symbol. You can use the following inequality properties to solve inequalities involving multiplication and division. These properties are also true for greater than or equal to and less than or equal to. So we have our multiplication properties of inequality and our division properties of inequality. All right, so solve. When solving, sorry, I can't even read. Solve, write the solution using a solution set. Graph your solution. All right, so the thing that we need to do here, we have x divided by 2 is greater than 3. So the opposite of division is multiplication. So we're going to multiply both sides by 2. So we're going to multiply both sides by 2. And we're going to get x is greater than 6. We did not flip our sign because we did not need to flip our sign. You only flip your sign if you multiply or divide both sides by a negative number. So our solution set, x such that x is greater than 6. Okay, and what did we use? We multiplied on both sides. So this was the multiplication property of equality. And they also want us to graph our solution set. So we have an open dot or a closed dot on the 6. It is an open dot because it's not an or equal to. And using our arrow trick, it shades to the right, towards the positive numbers. On our next one, we need to multiply. We're being divided by -4. X is being divided by -4, so the opposite is to multiply by -4. Right? We're going to multiply by -4. What we do to one side, we must do to the other. And so this would be the multiplication property of equality. I just skipped words. I skipped letters. Multiplication property of inequality. All right, so when we do this, we are going to get x. They already flipped the sign for us. And then, so it's greater than or equal to, a negative times a negative is a positive. 4 times 2 is 8, positive 8. So our solution set, x such that x is greater than or equal to 8. All right, and they had to flip or reverse the symbol. So you can either use the word flip or reverse the symbol because they multiplied both sides by a negative. So are we going to do an open dot or a closed dot on the 8? Closed, because it's or equal to. It includes 8. 8 is part of the solution. And we are shading to the right again. We are shading towards those positive numbers. Suppose the inequality symbol in part A had been greater than or equal to. Describe the solution set. Then the solution set would include 6. Suppose the inequality in symbol part B had been less than. Describe the solution set. So if it had been less than, my solution set would not, the solution would not include the 8, and yeah, that's it. It just would not include the 8, right? Because you still would have had to flip it because they're talking about the original problem. So the only difference would, it just would not include the 8. All right, moving right along. Let's see how much more we have to the homework. So your homework on this, just getting a little ahead of myself, but your homework on this is going to be pages 89 and 90. So we have a little bit more practice to go. We've got 2 more pages of notes. Dividing to find the solution set. Solve and write the solution in set notation. Graph your solution. So on here, 3x is greater than or equal to -9. So I don't want 3x's, I want 1x. And any number divided by itself is 1. So I'm going to divide by 3 on both sides, leaving me with x is greater than or equal to -3. I do not flip the sign because I'm not dividing both sides by a negative. So this negative over here doesn't make me flip the sign because I'm not doing that to both sides. So what I did here is I did the division property of equality because I divided by 3 on both sides. And my solution set is simply x such that x is greater than or equal to -3. So I go over to -3 and I put my dot. Is it supposed to be open or closed? It needs to be closed. It includes -3. And I am shading towards the right, towards the positive numbers. What do I do next? On negative 5x is less than 20. What do I have to do to get x by itself? Good job. Divide by negative 5. And since I'm dividing by a negative, I must flip the sign. So they already flipped the sign right there. So I get x is greater than negative 4. Okay, so they flipped that symbol, and they used the division property of equality. So their solution set, x such that x is greater than negative 4. Open dot or closed dot? Open dot on our negative 4. And we are shading towards those positive numbers, shading to the right again. There is a negative number in both parts A and B. Why is the inequality symbol only reversed in part B? Because in part A, you did not multiply or divide both sides by a negative number. Suppose the inequality symbol in part A had been greater than. Describe the solution set. The solution set would not have included negative 3. It would be all values greater than negative 3. Suppose the inequality symbol in part B had been less than or equal to. Describe the solution set. So the solution would have included negative 4. It would be all values greater than or equal to negative 4. So let's get some practice done. Solve. Justify your steps. Write each solution using set notation and graph your solution. So I want you guys to take a minute to try number 1. And they want you to justify your steps. What's the first thing I need to do? Divide by 4, right? So that would be the division property, or division property of equality. And using my arrow trick. All right, guys, look up here. See if you got it right. So I got x such that x is less than 8. I have an open dot on the 8, and I'm shaded towards the left, towards the negative numbers. Try number 2. So I use the multiplication property of equality. I multiply by 5 on both sides. X is greater than negative 15. So my solution set is x such that x is greater than negative 15. Open dot on negative 15. Shaded towards the right. Number 3. Try number 3. All right, so I multiplied by -4 on both sides, multiplication property of equality, and then I had to flip my sign. So I got x is greater than or equal to 16. So your solution set would be x such that x is greater than or equal to 16, closed out on the 16, shaded towards the right, towards the positive numbers. Try number 4. Divide by -2 on both sides, so you have to flip the signs. That's the division property of equality, and you had to flip. So you get x such that x is less than or equal to 3, closed out on the 3, going towards the negative number, shaded towards the left. And try our last one. All right, so I multiplied by -6 on both sides, multiplication property of equality. I had to flip my symbol, so I got x such that x is greater than -18. Opened out on the -18, and I'm shaded towards the positive number, shaded towards the right. Are there any questions on this? All right, well, I hope you guys enjoyed the lesson on 2.3, solving inequalities by multiplying or dividing. So you may begin your homework on page 89 and 90.